Now, for our chapter challenge, we tested the effect of distractions while driving. With a car going at a speed of 20 miles per hour, the speed limit in a school zone, we tested 4 variables. Those 4 variables were no distractions, a friend in the car, changing a CD, and texting. Now, what makes our data so reliable and credible? What happened is, we decided to test a fairly new car, a 2009 Toyota Prius, going at 20 miles per hour every time with the same driver, and at mile markers when we signaled for the car to begin stopping, we had 25-foot foot markers set up, and each time we would wave our arms at random one to ensure that we would not have bad data. Now, like we stated, we tested 4 variables in this experiment, but we also tested each variable 3 times to ensure more accurate and precise data. Our experiment entailed a person driving a vehicle down the road at 20 miles per hour with a person signaling with their arm when to stop. In order to ensure the most accurate data, we waved our arm at random 25-foot intervals to ensure that the driver would not know ahead of time of when to brake. This ensured an accurate reaction time and accurate data. The first of the tests we performed was driving with no distractions. This test was simply a person driving the car by themselves with no stimulus placed on them. It was during this test that we had the lowest recorded reaction time by Vallejo, as evident by his one trial of having a 2.72 second reaction time. This graph also shows the positive trend in the relation between reaction time and the time it takes the car to stop. The second of the trials we performed was having a person react to a person wave their arm down, with a person with them in the car. This graph shows a positive upward trend in the relation between reaction time and reaction distance, like we would expect. This graph is analyzed with the graph of no distractions. It is important to note that the total time for the car to stop went up by 0.5 seconds, which would indicate an increase of 0.5 seconds for reaction time. When we look at this video, we are able to get a first-hand look at just how distracting a person in the car can be. As Vallejo is trying to drive the car, Brandon is taking away some of Vallejo's attention
having a
towards
good day
the road.
today?
Yeah, I'm having a pretty good day. How about you, Mo?
Oh, I'm having a great day. What's with this song?
This
I
helps
hate
that
this
a
song. It's
distraction
way
of
too
someone
hot
in
in
the
here.
car can greatly affect reaction time. The third part of our experiment that we carried out was having a person drive the car while attempting to change the stereo. Like all other graphs to this point, we can see a positive upward trend between total reaction time and total reaction distance. From this graph, we can see that reaction times are somewhat higher than they were for driving with no distractions, but not as high as when someone was in the car. We'll be giving you another first-hand look here as we look at Vallejo try to change the CD in the car as he is driving. As you can see, his attention is focused away from the road. This is indicated in the graph as his reaction time was much higher. The final part of our experiment was testing a driver while they were texting. This was the most important test of all, in our opinion, as this is likely the one activity most drivers do more than anything else to be distracted, and this includes teenagers most of all. From this graph, we can see the upward trend we saw of all other graphs. Also, this graph shows a very significant increase in reaction time and distance for the driver. There is nearly a 1 second increase in reaction time for a driver, and being in a school zone at 20 miles per hour, this could be a difference between life and death. As we look at the video of the test, it is very clear Vallejo's attention is focused greatly on his cell phone, as results showed that he had none of his attention towards the road, with an increase from 3 seconds to 4 seconds as an average. Now this is the most important part of our entire experiment, where we put all the graphs together and analyze just how big of a difference the distractions made on all of our data. As you can see with the driving with no distractions graph in the bottom right corner and the time shown, the times for reaction distance and time were shown to have been nearly 1 second slower in many situations. If you look at all the other graphs, the following order comes in: changing a stereo, having a person in the car with the third lowest reaction time, and finally, driving while texting had the highest reaction time for all of the tests we recorded. For our conclusion, from this experiment, we can definitively conclude that driving while distracted, namely texting, can have a significant detriment on a person's reaction time as well as reaction distance. Now, the key part of Chapter Challenge is to figure out how the data and tests we performed fits into the real world. From our experiment, It can be said with confidence that driving while distracted results in an increase in reaction time as well as reaction distance. This essentially means that a driver distracted will take longer to react to a stimulus on the road. With going 12 miles per hour in a school zone, a 0.5 second increase in reaction time or more could be the difference between life and death.